Let's go through Lico 673, number of longest increasing subsequences. For this question, they give us an integer array nums, and let's find the count of the longest increasing subsequences. And we know there is a question about ask the longest increasing subsequences, which just give us an integer array, find the longest LRS. That is a very classical problem. And for that question, we have two solutions. One is use DP, right? And another is binary search. For the DP solution is that we have two follow-up. One is for every I, right? Iterate from, for example, 1 to n, right? And another j that we have an inter array dp, right? Means dpi means the length of the longest increasing subsequence end with index I. And so what do we do is that we use a for-loop to iterate I, and also use a for-loop to iterate j equals 0, j smaller than I, right? So we compare if nums j smaller than nums I, right? Then we try to update with the dpj plus 1, trying to see whether can update the dpi, right? Find all of the nums j smaller than num I, the greatest dpj plus 1 to be the dpi, right? And for every index, and for example, we have the result, right? After we get to the dpi, right? We need to for every index, we have the result to compare with the final result to get the longest one. And for this question, we need to also have the counts, right? So what we're thinking about is that for this DP, we are going to use two dimensions. One is so will be n multiplied by 2 dp, right? So dpi0 will be the length of the counts. That is LRS length, and dpi1 will be the count of the longest increasing subsequence with n with I, right? So for dpi0, what we calculate is the same logic as the LRS1, right? And for dpi1 is also similar, is that we iterate those kind of nums j smaller than dpi, right? So we find if this kind of dp, if there is a number j, nums j smaller than nums I, if there is dp j 0 plus 1 greater than dpi 0, right? Then we need to update this dpi 0, and also set this dpi 1 is count to dpj1's count, right? And if they equals, right, then that means for this kind of longest increasing subsequence end with I, there is a new contribution. So the counts will add this dpj1's counts, right? And after we calculate every dpi0 and ij j0, right, we have a global result and a global counts to add to the result, right? So if this dpi0 greater than the global result, then our account will set to this dpi1, right? If they equals, that is added to, right? So after this analysis, we just are doing a write code. So we're going to have int n equals num stop length, and we're going to have a dp. Now we use a multiple by 2, right? So we know every number itself can be a LRS, right? So the length will be at least 1 and the count will be at least 1. So we can do for int in dp array spell ds1, right? We're going to have a max length and count. We can set this one as 1 and result that is our count equals to 1, right? So that we can put int I equals to 0, I equals to 1, right? If we iterate from 0, we should set the result as 1 because we just want to iterate once, right? And that will add to our result. So set this result as 1 if you set iterate I from 1. Okay. In I smaller than I plus plus. And what we do is set for int j equals to 0, j smaller than I, j plus plus, right? And I will say if nums j is smaller than nums I, right? Only in this case, that means our nums I can add to nums j, right? And we'll say if dpj 0 plus 1 is greater than dp I 0, means we find the longest one, right? This one is a new longest one, it's a maximum. Then we'll have dp I 0 equals dp j 0 plus 1, right? And also we have dp I 1. That will be the same count as dpj1, right? And here we'll say else if dpj0 plus 1 equals dpi0, right? Means for this kind of longest increasing subsequence, there are multiple j's added to our result. So we'll have dpi1 to the plus equals to dpj1, right? So after this for j loop, right? We every dpi we have a dpi0 and a dpi1, right? So we do similar logic. Similar logic is if dpi0 is greater than max length, right? Then we'll have result equals dpi1, right? This counts. And also we have max length equals dpi0. And let's say else if this kind of dpi0 equals max length, right? That means for this kind of max length, there are multiple contributions. So we'll have result plus equals to dpi1, right? In the end, we just return result. The time complexity will be n squared, right? And the space will be n multiplied by 2. Right, the JSON code should be very similar. We have n equals length nums, right? And we're going to initialize this kind of DP array equals 1, 1 for underscore in range, right? And we'll have max length and result equals to 1 and 1, right? We'll have for I in range from 1 to n, right? If you want to set as 0 to 1 to n, you should have a result added to set as 0 because remember in the later part we should add it to the result, right? If you don't want to have this, you can set this one as 0. So what we do is for j in range R, right? So let's say if nums j smaller than nums R, in this case um, there are several scenarios, right? If dp j0 plus 1 smaller than dpi0, there is no contribution. There is no new, no longer um, sequences found here. So we'll do nothing, right? So only when dp j0 plus 1 is greater than dp I0, right? And equals to. Then for this one means we find a longer one, right? So we have dpi 0 equals to dp j0 plus 1. And also this dpi1 should be initialized as dpj's counts, right? And we'll have else if dpj0 plus 1 equals that means for the maximal longest increasing subsequence and always this I, right? There are multiple contributions, so we have dpi 1 plus equal to dpj 1, right? So after this for loop, that is dpi 1 and dpi 0 already been calculated, right? So we say if dpi 0 is greater than max length, right? So we have max length. Of course, we need to update with dpi 0, and our result, right, should also initialize to be this dpi 1, right? And we'll say else if, right? Else if dpi 0 equals max length. That means for this kind of max length, we have multiple contributions. So we have result plus goes to dp 1, right? In the end, we just return result.